Hey there, my name's Ace. Thanks for giving me some of your time. Today, I'm introducing myself through a special opportunity to discussing biomimicry from my perspective. And I intend on shedding a little light on the journey I took to discover information that has the potential to change the world as we know it. Now you might be sitting there thinking, change the world? Okay, this guy's nuts. And I would have to agree. I am a little nuts, but it's an intellectual kind of nutty. Anyway, the beautiful thing about designers who report to nature's fundamental values first is they tend to have a cleaner, stronger, and more resilient concept for innovation that's applicable metaphorically and literally. The adventure of the process involves collaboration, humility, an open eye, and lots of questions. You can ask just about any biomimic if they've discovered something that they believe is world-changing. I'll bet you they'll tell you they believe they can make a better environment for their respective communities within their personal and professional lives. Now, before I tell you just how weeds can blow your mind too, you should understand that prior to identifying as a biomimic, I was always searching for answers to my life's challenges by connecting with nature as much as I could. My decisions were based off of my personal experiences and lessons I've learned whilst living off the grid in a school bus, working as a farmer, a beekeeper, an animal behavioralist, a 911 dispatcher, basically just a guy trying to survive as sustainably as possible in a society that makes sustainability look impossible. Now, the world through my eyes is complex, it's exciting, and it's vibrant. It's full of interconnections, made up of many different levels and full of question marks. So without further ado, this is my story of how biomimicry has opened worlds I hadn't even imagined. When I first began brainstorming for what my VDL was going to look like, I was certain that I was going to write some sort of excerpt that was theoretically pulled from a book I've written that would act as some type of manual. I foresaw this book teaching folks, anybody, beyond students or educators, how to apply biomimicry to their everyday lives. Implementing a new way of looking at your daily tasks. There could be a chapter on eating like a biomimic, or how to be a biomimic and a consumer, and so on. How would biomimicry shape shipping systems and materials, bathroom necessities, your daily commute, running a business, or developing relationships? I wanted each excerpt from my book to be about a different niche in the average American's life, from there expanding the biomimic bubble to those who may not even have an education. I guess assuming that most everyone is still reading books, theoretical books. After much deliberation, a little bit of deliberation, I chose to focus on packaging and shipping systems and materials. I thought I could embrace both the metaphorical and the literal, the systems and the materials, in one VDL, ending off with a few concepts for each that could be applicable to the average consumer. Great idea, right? I mean, we all participate in the mailing system, either receiving letters, packages, bills, or sending them. I mean, this is a huge challenge in of itself, and the broad implications of the entire system would really make it difficult to find just one or two areas of focus. But hey, what the hell? Let's see how I can make this work. One of the fundamental requirements of this project, and of biomimicry thinking in general, is that it is built on collaborative efforts, and as much of them as possible. I came across Jeff Boudwin and his concept of leveraging weeds and addressing their negative connotation and trying to transform perspectives and attitudes.
Hi, my name's Jeff.
I decided to jump on board with Jeff, and I made a commitment to allow weeds to teach me something that could change the world. Somehow, somewhere, some weed was going to teach me how to teach others just exactly how to live by nature's principles. More specifically, I guess I was going to teach everyone how an individual can transform shipping systems and materials from inside and or outside of the system, consumer or employee.
And Kira Hunt also had her interest perked by this concept.
Yo, Kira here.
She, though, is determined to change business systems and thinking with the skills of nature, more specifically, the skills of weeds.
We ended up calling ourselves Team Weed. As a team, we took a random pick of 10 plus weeds per person, so that's 30 plus. We tried to search for mechanisms and traits that appeal to us. We focused less on what our end goal was, asking ourselves things like, okay, what does this weed do that's really cool? How can I somehow apply it to the real world? Team Weed taught me that as designers, no, as biomimics, we should focus more on walking out of the forest with new tools, new ideas, new concepts, rather than bringing our ideas and our tools into the forest. Well, the three of us, being the overachievers we are, ended up with a list exceeding 40 plus weeds easily to study and to discover interesting things that may or may not apply to the human design world. In our little world of biomimicry, we call this a deep dive, and you better be ready to put on your reading glasses. The cool bit to this, for us, wasn't just the hopeful discovery of something cool. Shoot, we knew that we were going to find amazing things. It's nature we're talking about here. No, it was more the excitement of transforming the perspective of a weed, this annoying, virulent little thing that just won't go away, this negative connotation, some might say a stigma, being transformed into a powerful and respected organism. I'd like to think that maybe at the end of the day this story is like a prescription of gratitude. It didn't take too many articles to see that weeds have been developing their badass mechanisms for millennia. In biomimicry, this is where the 3.8 comes in. 3.8 billion years of learning, adapting, and evolving. I have no idea what to do or what to expect. I'm so young and unexperienced, especially compared to nature in general. It's one of the first lessons we receive in the biomimicry thinking classes. We, as in humans, are only a momentary blip in the overall calendar of the planet. So in essence, weeds made me realize again that I've barely started my career in biomimicry. How was I supposed to write a book on living by nature without more experience of actually living by nature and putting it to the test? If weeds have been getting their roots dirty for millennia, then, well, I guess I need to open my eyes and see what they can teach me first. I mentally scrapped the idea of my book, knowing that something much cooler was in store for us. Time to bear some roots and start settling in for the journey. Oh, yeah, and by the way, that journey, the deep dive that I'm summarizing all nice for you, it's a condensed version of about 60 plus pages of notes, quotes, and references I accumulated over a period of about 4 to 6 weeks. It all started with hemp. I'm sure we all know it's full of incredible mechanisms that allow us to clean up our toxic messes with, plus a whole plethora of other cool things. It's unfortunate that we're not utilizing hemp in all of those other markets, but that's a tangent for another day. The utilization of hemp plants surrounding Fukushima, for example, is called phytoremediation. We are taking advantage of this plant, technically a weed. More specifically, its adaptations to clean up some of the most destructive and toxic chemicals known to man. The ability to be able to do this, to clean up the environment, that's bioremediation. So there's all sorts of ways that plants bioremediate. Weeds are particularly good at it, and hemp is one of the best. But some plants are better at some metals, while other plants can be killed by the same heavy metal. It took me a second to get it, but context is very important to understand. Depending on my situation, I might want to bioutilize a plant that can remove excess lead in my soil. I'd need to be careful though, because other heavy metals, say arsenic, might be fatal for the plant if contact is made. Here's where a lot of my time went into. There's so many plants and so many metals that can be connected. I wanted to understand each different type of bioremediation technique. I thought at the time I wanted to pull an ADP for each, because what good was knowing one piece of the puzzle? A lot of time goes into fully understanding just one mechanism, and a lot of cross-checking should be done during this process. you're likely recognizing a bit of the complexity starting to unfold. And I didn't even mention all the metals and how each metal is handled in each of those mechanisms. It's, it's as unique as our fingerprints. Now take into consideration that many plants can perform one or two or more of these functions at once, and sometimes the mechanisms are so different depending on the heavy metal in question, and the plant, and the context. But, nevertheless, through all of that, it came to my attention that hemp, cannabis sativa, and a few others stood out as champion weeds at transferring toxic metals from substrate and water and storing them. Though it should be acknowledged that it shares this trait with dozens of other weeds and hundreds of other plants. It's not an uncommon strategy found in nature. It's a pattern. Most plants, and nearly all weeds, do it a little bit differently. Some volatilize, some stabilize, some degrade, some simply just store. But at the end of the day, removing metals from the environment is the key. Importantly, I learned that plants have limits. They can only store so many metals before becoming poisoned. They can only distribute so many metals before losing strength. Now, doesn't that seem odd? I mean, if there's this limit and boundary implication, how come more plants aren't dead? I mean, I know a lot are dying and we're in this horrible place right now, but if, with the amount of heavy metals we've thrown into our atmosphere, I don't know. It seems like plants are still thriving in many contexts. So, that stuck with me. Here I am, upwards of 60 pages of research, and abstracting all these design principles on gradients for all of them, learning how each of these mechanisms can influence the micro, meso, and macro scales. And I still felt like something was missing. It felt like there was more to the story. That whole point about plants having a threshold struck me as odd. Not odd as in, oh, that's not who it should be, but it's expected, right? Just like we can poison ourselves with too much of anything, so can plants. Okay, side note. During this whole process, Teamweed was effectively holding its members accountable. We each started at the same line, weeds, but with different contextual focuses. Chatting with one another at least once a week, often times multiple discussions were had about our individual yet parallel paths. I thought this was it. A part of me thought that I had this really cool piece of information, and it could be translated for multiple metaphorical and literal contexts. It was my job to speak on nature's behalf, and I had to get it right. I mean, what good is my research if I, one, don't feel comfortable about it, and two, feel like there's a piece missing? Well, I didn't quite know there was a piece missing, but I didn't feel confident. So I decided to take my findings to some of my buddies who are biologists, and they work at the local university. Now don't get me wrong, I know I had some pretty awesome stuff here. These mechanisms on cellular and molecular levels are absolutely fascinating, and that's how I approach my biologist friends. I wasn't going to choke myself up on what I was feeling. Not just yet. Okay. You know, every story has to have a climax. There's this steep climb that takes all this energy, commitment, and motivation. Well, I don't know really how great of a story this is, so just know right now we're climbing that hill together, and one of my friends, who is now one of our friends, is about to attempt to push us off of it. Hey man, get this! I discovered all these neat ways that plants can bioremediate. Check this out. It's amazing how complex and interconnected it is. I think I can make some really cool concept from the principles I've come up with. Oh, dude! You're talking about the bacteria, right? How they do all the heavy lifting and plants are just soaking up the attention? Whoa. Wait. What? No. That can't be. What did I miss? Yeah, well, I missed something indeed. I missed a whole subworld. Shoot, I missed a whole new context of information. Well, actually, in hindsight, I didn't miss it completely. I unknowingly avoided it. You see, all the articles I found, and I found dozens, stuck specifically on how plants transport metals in their systems. because my keywords in my searches in all of my research were focused on how plants specifically manage these heavy metals. By only using words like phytoremediate, bioremediate, phytoextract, phytodegrade, phytovolatilize, rhizodegradation, and so on, I essentially constricted the quality of information I was getting without even knowing I was doing it. It's kind of something that just happens with the learning process. And over time, you learn vagueness can be used as a tool. Turns out there was a specific word that I didn't recognize, and I didn't make myself research it, and I didn't dive into it. And I think if I had, I would have known better prior to this. But we'll get there. For now, your mind's blown, right? Bacteria? Metals? Wait, I still want to figure this out. So this is a serious contextual piece of information that hadn't originally occurred to me. I really couldn't try and sell hemp as this amazing metal detoxifier on our planet, a champion, if it wasn't actually performing this trait on its own. How could I design an incredible concept to an incredible invention if it is based on only half of a principle? It's only half as good as its counterpart, right? No, if what my friend told me was true, which I'm assuming it is, then I need to completely retrace my steps. I mean completely. By jumping back to the discovery phase, remember the 60 pages of research that I thought was everything? And learn about bacteria's role in bioremediation. Else all of my conceptual designs that built off of this mechanism will be more likely to fail and sort of lacking of luster. And you know, something else I want everyone to think about. Does anyone notice how bacteria and weeds have the same kind of negative connotation, stigma? Think about that. On top of going over the articles I reread, now knowing what I know, I found dozens more articles and studies on bacteria's bioremediation capabilities altogether. In fact, 2 of the articles that I downloaded previously to knowing this fact about bacteria actually mentioned endophytes. Okay, so humor me here, and let's assume you're me and you don't know what endophytes are. It's bacteria that reside in and around plants. Oh, it sounds so obvious. Presumably, because I didn't recognize the word, I must have skimmed over it, never realizing that I just glanced right over my gold mine. You may remember earlier, I brought up a word, humility. Now this is where it comes in. You've got to acknowledge when something just misses your understanding. Sure, you can probably piece together what it is after further reading, hours and hours of reading, but if it's done right, it could end up being a critical piece of the puzzle like this. You must collaborate with specialists of all kinds of different fields. You just have to. It's impossible to know everything, and even if we have all the information at our fingertips, we still can't possibly know what it all means. Yes, it's probably a needle in a haystack, but imagine for 1 second a needle in a stack of millions of other identical needles, and you can only recognize that needle by a color, a smell, or a taste. And the catch is, you don't know what it is until you've come in contact with it. Those needles are the words, and the haystack of needles is all the articles and information on subjects you're researching. And I tell you what, your biologist friend, he smelled that smell before. Yeah, we're just going to go with that metaphor. Okay. In a nutshell, I learned that bacteria reduces the toxicity of soil and water before the roots of plants even touch those toxic metals. In fact, without bacteria, there'd be no way, no chance, they could survive after just a little bit of this heavy metal toxicity. Plants rely on bacteria to be able to do their jobs. So can plants regulate themselves when exposed to metals? Yes, definitely. But can they do it without bacteria doing it first? Not really, not sustainably. So what's the moral of that extremely climactic part of my story? Well, you could take 2 things from it. 1, you can memorize every word in every language and its coinciding definition, or you could utilize collaborative measures. Save some time and talk with a specialist, in this case a biologist. But maybe you're a biologist and lack the system expertise of an engineer. That's okay. Opening up those lines of communication will almost always serve you and your project well.